What's up everybody, this is the fourth part, the last part in this video series about a box of scrap components I picked up last November. Yes, it did take quite a while to get here. I just had a really hard time sorting through hours and hours of recording, narrating everything, but in light of what's coming up in my life, I really should probably get going on this backlog of things here. There's a couple more videos about other stuff coming up, but for now let's focus on this box and the sound cards I found in it. This includes some interesting repairs, so stick around, you might like this. As per usual, you're gonna hear some familiar voices from the RetroWeb Discord. Here's an example.
Is the head up the ass too?
Well, it depends on configuration. Let's start with some really easily digestible stuff. Here's a C-Media 8738 based PCI sound card. This chip has a mixed bag of reputations. If you get an early revision of the chip, you're in for a treat because it does actually work quite well with Windows and DOS. In fact, it has a 100% faithful OPL3 emulation inside. It's actually not an emulation, it is a true hardware synthesizer based on genuine, well I say genuine, they were stolen, chip masks from Yamaha. Early enough revisions of this chip are in fact not only Sound Blaster Pro but also Sound Blaster 16 compatible. That is, if the stars align and you get it to work, which again is not trivial and requires the right chipset revision. The legacy features were all but thrown out by the year 2001 or so. This one sadly is not one of the good ones.
That doesn't sound happy.
Yeah.
Well, at least the driver comes with a software wavetable synthesizer.
In-game it's actually called.
Well,
Wow, that is the worst MIDI synth I've ever heard. Well, can we at least play Doom?
Well, DMXing it still crashes the system.
I guess not. What about Duke Nukem 3D?
Invalid or conflicting DMA channel.
It worked in the sound test! A few driver installations later.
I get this result.
Well, what were you benching there that was...
Well, I guess that finally works. Maybe this is the beacon of light we've been hoping for.
Yo.
It never bide. Next up we have a Creative Sound Blaster Live. It's not a great card, it's not a bad card, it's got EX support, has a pretty decent synthesizer, and fairly good DOS compatibility. Unfortunately this one is broken, inserting it prevents the entire system from posting. In fact, the whole machine is being held in reset. This thing is sourcing current from the PCI bus signals. And as it turns out, there's a short on one of the voltage regulators. That didn't go away until I desoldered the main chip. Pretty rare that these chips break, but you can see a clear scorch mark below the chip there, and also a crack across the die. I guess this is one of the few components I found that truly deserve to be scrapped. I'll still keep it around as a donor PCB because you never know when you might need it. Next up we have an Ensoniq Soundscape Opus version 2. Ensoniq cards back in the day were known as cards of higher production quality, better sound quality than Creative products, for example. Most notably, these Ensoniq cards use a 4-layer PCB design, whereas the Creative cards only used 2 at the time. Soundscape, albeit less popular than Sound Blaster, was a recognized standard that many applications supported separately. To top it all off, this card has the Opus wavetable chip, which should give us pretty decent quality MIDI sounds. This card is a plug-and-play variant, and there are drivers for Windows 95, which I was able to use. And in Windows, while the wave sounds were unproblematic...
Oh, it works.
The MIDI sound was not.
There's not enough memory available for this task. What?
However, in DOS applications it performed brilliantly. Listen to a duo on this thing.
Pretty good, like you could totally play the game through this and more or less the authentic experience.
I agree completely with that assessment, but one quirk of this card absolutely has to be mentioned before we move on. This card does not have OPL emulation. It has OPL3 approximation, much like the Trident 4D wave we showed last time. It tries to approximate OPL sounds by mapping them to wavetable instruments, which is
Oh no. What's this?
Not great.
Oh.
This sounds a bit weird.
Credit where credit is due, some of the sounds are recognizable, but it's really not recommended. And with that, on to the next card. Here we have a MediaVision Pro Sonic 16 based on the MediaVision Jazz 16 chipset. This card also sports a genuine OPL3. The DOS driver package comes with a convenient installer which works fine at first, but on my test bench it glitched out and crashed upon doing some hardware detection that it insists on. After testing all kinds of BIOS configuration options, I saw no other option than to skip this installer entirely. I looked at example command lines and tried to use one of them to load the driver myself, which yielded a screen hinting at successful configuration. Quickly tested the card in Descent.
Oh.
Oh, that's low. Works.
And then did a full test of the OPL3. Being a genuine chip, working perfectly of course. Doom worked perfectly as well, but other software did not, for example OpenCubic Player. But another mod player worked, so meh.
Wait, I can't use that in my YouTube video. It'll be copyright striked.
Windows 98 already comes with a driver for this card, but it's not a plug-and-play card, so it needs to be installed by hand.
Certainly sounds like a sound card.
Just for shits and giggles, the Jazz Jackrabbit theme on the Jazz sound card. Here we have another card with a wavetable synthesizer. This is an Aztech Wave Rider 32 Plus. Pay attention to the FCC ID because that's what's used by Aztech to index all their drivers. One driver installation later and we have Windows sounds. Maybe not. Okay, this was fairly trivial to diagnose. The card insists on configuring itself for IRQ 10 in Windows. Just block that IRQ in the BIOS and hey presto. Ah. Now, IRQ 10 proved to be difficult to deal with for DOS software, but more importantly, I couldn't get the wavetable synthesizer to work at all. It didn't find an MPU compatible device or anything. So I decided to look into the basic configuration and went into DOS for that. The card comes with a fairly comprehensive config tool, so once I enabled everything I was able to load a wave-tied TSR. And once I did that, it provided an MPU 401 compatible interface on port 330. It's a shame that the Windows driver seems to lack this feature. And I could finally get Sound Blaster to work. Still, the TSR approach did come with its caveats. Some software really didn't like it, such as Descent. Duke Nukem 3D, however, was really happy with it.
Let's rock.
Here's the most annoying quirk on this card. It has a genuine OPL3, which in theory is stereo. However, it does seem to be getting mixed together in mono, even though you can control its output individually on both sides. very annoying and really takes away from the immersion you get from the OPL synthesizer. Last but definitely not least, a Sound Blaster Audigy 2ZS together with the front panel extension. That's quite neat. However, there's a small problem. It doesn't get recognized by the system. It doesn't show up in either the PCI listing in the BIOS, nor does Windows prompt you with an installation dialog for new hardware. Skipping over quite a bit of troubleshooting, the relevant bits to configure the chip to appear on the PCI bus are stored in a configuration EEPROM. The Audigy 1 series did have a problem with corrupting its own EEPROM, but I've never seen that happen on an Audigy 2. Just to make sure, I decided to investigate. I desoldered the chip, put it on an adapter PCB, and then read it out. To my surprise, the second half of the EEPROM seems to be filled with garbage. Whereas on working dumps from other cards, such as the Audigy 1 and the Sound Blaster Live series, there's always sane data there. So I decided to copy over this data, which seems to be identical between Live and Audigy, into this corrupted EEPROM dump and write it back to the chip. I said write it back to the chip. Okay, so it seems that this EEPROM is dead. Where could I potentially find an EEPROM for a creative sound card? Where indeed? I'll still keep it around as a donor PCB because you never know when you might need it. Right, so I guess I found a use for that thing already. Just take off the EEPROM, put it on the programmer, write the new binary, solder it back in place, and hey presto! The driver is installed without a hitch, and now that's what I call a success. Well, that's it for the two scrapboxes. That was all the things I could reasonably show you guys in YouTube videos. There were a few boring cards like 8400s or 7300 GTs, like really boring stuff that I ended up repairing. Not really worth making videos about, but everything that's worth showing I've shown you from those two scrapboxes. It's taken a long time, but here we are. A special thanks go out again to the great folks at the Retro Web, without whom this probably wouldn't have happened. That being said, I got a whole bunch of stuff to sort through, got a whole bunch of unedited video footage. I have a few cool videos coming up. Thank you so much for your attention. I will see you next time. Bye bye.